Good day, grade 7. So this is Sir Ian, and in this video we will be giving additional reminders regarding free body diagram. And one of these reminders is all about forces applied at an angle. Example scenarios um, of this can be seen in these pictures. For example, this child is pushing this object at an angle. On the other hand, this guy is pulling this box at a specific angle. Now, in both cases, um, they have y and x components, meaning these forces they applied have horizontal and y components. Okay? Now, we need to get these components, the horizontal force and the vertical force, because it will help us to determine whether the object will move horizontally or it will move vertically. Now, um, we focus on this illustration. So, this or the force that this person is applying can be represented by this arrow. Okay? And let us assume that this force is applied um, at an angle of 30 degrees. Okay? 30 degrees in relation or relative to the surface. Okay? So, between the surface and the force applied by this person is the 30 degrees angle. Now, the x component, okay, of this force applied by this person is represented by this arrow. Okay? Until here only. Until here. And then, the vertical component of this force can be represented by this broken lines. So, if we will be combining them, the x component, the y component, and the overall force applied by this person, we can form a triangle. So before we be able to get the x and y components, we have to determine first or label first each side. Okay? Now, do not forget this, that the overall applied force by the person is the hypotenuse. Okay? So meaning the 200 newtons is the hypotenuse. Okay? That is the overall force applied by the person. But then again, this 200 newtons has x component, which is represented by this and also y component that is being represented by this line or broken lines. Now, so since we have already the hypotenuse, now, how about f of y or the y component and the fx or the x component? What are those sides? So, since we have already the angle, which is 30 degrees, we can easily actually determine or label the sides. Since we have here the 30 degrees, what is in front of that is the opposite side. So therefore, the vertical component, which is f of y, is our opposite side. So take note of that. That is our opposite side. O. And then, the F is, or the overall force applied by this guy is the hypotenuse. Okay? Now, since we already have the opposite side, we have the hypotenuse, obviously, f of x is the what? Adjacent side. Okay? That is the side shorter than the hypotenuse. Okay? Now, so since we have already identified the sides, we can already derive the formulas to get them. The f of x and the f of y. Okay? This time, we will be using the trigonometric functions. Sine, cosine, tangent. Or the SO, CA, TOA. Okay? Why SO? Because that represents SOH. SOH meaning sine theta, okay, is equal to the O, which is opposite, divided by the H. So, which is, H is hypotenuse. Okay? Ka, meaning cosine theta is equal to adjacent, divided by hypotenuse. Ka, CH. C-A-H. Okay? Ka. Then, TOA, tangent, theta is equal to opposite divided by adjacent. TOA, tangent, O, opposite divided by adjacent. TOA. Okay? Now, since we need to get, first, let's say, f of x. Let's focus first on f of x, which is the horizontal component. We need to get the adjacent side. And among the trigonometric function, which one has adjacent sides? Sine, cosine, or tangent? Okay. Among them, the functions that have the adjacent sides are only cosine and tangent. So we remove, in our choices, sine. Okay? So we will just choose between cosine and tangent. Now, since in this situation, we already have the hypotenuse, which is the overall force applied by this person, then we choose the equation that has hypotenuse. So between the two, which one has the hypotenuse? Okay, obviously, it is the cosine function. So, we remove tangent in our choices. So, we will be using the cosine function. Now, we need to make adjacent isolated on one side. Okay? Kailangan iwanan natin sa adjacent side so that we can get its value. Okay? So, to do that, we need to make the hypotenuse be on the other side. Since cosine theta and hypotenuse, they are inversely proportional, we can place the hypotenuse on the other side by allowing them to be multiplied. So, hypotenuse hypotenuse sorry, wait, times wait. Again, we have to isolate adjacent. It's because that's the one we are looking for, the f of x, adjacent side. So, again, hypotenuse should be on this side, hypotenuse times cosine theta. So, we just remove this hypotenuse on this side, and we just allow adjacent to be a load on that side. So, we remove that. So, our equation will be adjacent side is equal to hypotenuse times cosine. Or, will be this. F of x, which is equivalent to adjacent side, okay, is equal to the hypotenuse, which is the overall component or force. So, F cosine theta, which is the angle. So, if we will be getting the horizontal component, it will be f of x is equal to F, which is 200 newtons, times cosine, which is the angle, 30. There we'll get our f of x, which is the horizontal component of the force applied by this person. So, 200 cosine 30 will have 173.21 newtons. So, our f of x is equal to this. 173.21 newtons. So, if we will be comparing this arrow, okay, to this arrow that ends here, that ends here, the longer one is the hypotenuse, which is 200 newtons. Here, it's only 173.21 newtons. Okay? Nevertheless, we'll move on by getting the f of y, which is our opposite side. Okay? Now, among the trigonometric functions, which one are among them, what are the equations that have the opposite side? Okay. Both sine function and the tangent function. But, which function has hypotenuse? Why we are looking for the function that has hypotenuse? Because we already have hypotenuse. So, we need to use a function that has hypotenuse so that we can maximize that equation. Okay? Or we can maximize the hypotenuse that we have. So, Between the two, the one that has hypotenuse is the sine function. That is why we will be using that function. Same process. We need to isolate the opposite side, which is our f of y. Now, to isolate that, we need to make the hypotenuse be on the other side. Again, since they are inversely proportional, we can just multiply them. We make the hypotenuse be here, multiply to sine theta. So we remove that because it's already here. So our equation will be opposite side, which is f of y. Fy could be called that one as well, as f of y. Opposite, or f of y, fy is equal to the hypotenuse, which is our overall applied force, times sine theta, or the angle. And that is the reason why we have this equation. F of y is the opposite side, is equal to f, which is our hypotenuse, this one, times sine theta, which is the angle. That's why we have this equation. So let's get the f of y. F, which is the hypotenuse, 200 newtons, sine theta, which is the angle, is equal to, let's compute, 200 sine 30 will have 100. Newtons. So our f of y, or our opposite side, is equivalent to 100 newtons. So meaning, the length of this arrow should be shorter to the hypotenuse and the adjacent side because it has the lowest amount, 100. So is it shorter than the hypotenuse? Yes. Is it shorter than the adjacent side? Yes. So, that is why I think we got the correct illustration and answers. Okay, now after getting the x and y components, let us check or predict whether this force being applied by this guy is enough to make this box move on this side. Okay? Now, let us assume that the floor applies a friction force. Okay? Of negative 50 newtons. Or we make it shorter. Newtons. Okay, so the friction force is along the x-axis because it is the surface or the floor that forms a friction force with the object. And usually friction force is um, having negative sign, or usually it has negative sign because it opposes the motion of an object. Okay? And the force acting along the x-axis is the x component. Okay? The x component of our applied force. And the x component, if you can still remember, or the horizontal component is the f of x. Now, earlier we got already its value, which is 173.2 or 21 newtons. Now, since we have a friction force here opposing the motion of this object, then we have to add it. So we have negative 50 newtons or plus negative 50 newtons. So we get the resultant vector or the net force. So let's calculate 173.2 or 21 plus negative 50 newtons, then we'll get 100. Let's fix this first. Plus negative 50 is equal to 123.21 newtons. So now, knowing that we have not negative, 123.21 newtons along the x-axis, then will the box move or not? Okay. So since our net force is non-zero, it means the forces acting along the x-axis are unbalanced, meaning the object will change its motion or it will move from rest. Okay? But if, let's say, the friction force is negative 173.21 newtons, then our resultant vector B will be 0. And it means that the balance or the forces are balanced, therefore it will not move. But since we have non-zero, then it will move. If you have any questions or clarifications, you just message me and do not hesitate to ask help. Thank you.